Okay, let f be the function. So here's my formula for f. G is differentiable. And here, and g of pi over 2 is 0. The graph of g prime, so this is g prime, derivative of g is shown below. Find the value of this limit. Okay, the fact that they're asking to find a limit of a ratio right away reminds me of L'Hopital's rule. So maybe I'll need L'Hopital's rule, maybe not, but decent chance. Okay, so to find limits, I first check to see if x is approaching infinity. It is not. I'm trying to find the limit of f divided by g, and I don't even have a formula for g. There is no formula given for g. So factoring and dividing is not going to work. Left and right limits. So I think about what's happening here. As x gets close to pi over 2, this is the graph of g prime. Interesting. As x gets close to pi over 2, let's see what happens here. For f, when x is near pi over 2, that'd be e to the pi over 2 times the cosine of pi over 2. Cosine of pi over 2 is 0. So it does appear that the limit, as we get close to x approaching pi over 2, that limit is going to get close to 0 over 0 because the value of f is getting close to 0, and they told me that the value of g was getting close to 0. So I'm going to use L'Hopital's rule and create a new limit problem. Copy this over. All right, so got to create a new limit problem. So let's erase this. Let's move this up out of the way. Okay, I need the derivative of f. So f prime requires the product rule. So take the second, which is cosine of x, multiplied by the derivative of the first, e to the x, plus e to the x, multiplied by the derivative of the cosine of x. So that means f prime is going to equal cosine of x. Derivative of e to the x is just e to the x, dx over dx, plus e to the x. Derivative of the cosine is negative, so I have to have the parenthesis, otherwise it looks like I'm subtracting dx over dx. So my f prime is e to the x cosine of x plus, actually minus, e to the x sine of x. G prime, I have no formula for g. I do have a graph of g prime. That now makes some sense why they gave me the graph of g prime right here. Oops, wrong button. So that does make some sense now why they gave me this graph. Get the pen to work. Because this is g prime. Okay, so I'm going to need this, and I need to copy this over, get some more space again. Okay, so my new limit problem is, L'Hopital's rule says, so per L'Hopital's rule, the limit as x approaches pi over 2 of f divided by g is the same thing as the limit as x approaches pi over 2 of f prime divided by g prime. Okay, for f, my f prime formula was e to the x cosine x minus e to the x sine of x. So the e to the x can factor out. This is a hard problem. Lots of details. Okay, when we get close to pi over 2, this gets close to 0. This gets close to 1. So this entire limit gets really close to negative e to the pi over 2. That's what's happening to the limit as x approaches pi over 2 at the top. When x gets close to pi over 2 on this g prime, we're getting close to a y value of 2. So this limit is going to be pi over 2 divided by 2. You don't have to reduce anything. You can leave it just like that. The points they award on this one are, don't forget the negative. Oops, I messed up there. E to the pi over 2. So this one here. Negative e to the pi over 2, all divided by 2. 2 points for this one. 1 point for recognizing that you had to apply L'Hopital's rule and find that derivative. And then a second point for finding that value.